This is tutorial number 181, and it covers how to use sketch blocks within Solidworks. To start off, let's open up a new tutorial part. Let's click File, click New, click Part, click OK. So in this tutorial, we're going to be covering how to use sketch blocks, and what a sketch block is within a sketch, you're able to call it a sketch block, and from that, you're able to add constraints and relations to all your different sketch blocks, and you're able to actually simulate a motion of, say, like a machinery, or to see if it'll fit in some kind of packaging space. So you're able to, within a sketch, make multiple sketch blocks, put relations on them, and move them around. So what I'm going to do in this tutorial is just introduce you to a sketch block and just show you how to make sketch blocks within an individual sketch. So to start off, click Sketch, click Circle, click the front plane, and just draw a circle in the top left corner. And don't worry about dimensioning it or anything. Click OK. Now to get and create this as a sketch block, you're going to have to click Tools, click Blocks, click Make, and it already has the arc selected as a sketch block. So let's click OK. And now you can see on the side here that you now have a sketch block. Now let's draw another shape. Let's draw a rectangle down here. Don't worry about dimensioning it. Click Tools, click Blocks, click Make, and again it's already been selected, so you have all the lines. Click OK, and now you have another sketch block. Now this time, let's draw a circle in the top right, and let's draw a line right beside it. Now let's click Tools, click Blocks, click Make, and now you have the line selected. Now let's also click the circle, click OK, and now the line and the circle are in the same sketch block. So if you click on there, you have a sketch block there, a sketch block there, and a sketch block there. Now within here, you're able to add dimensions, constraints, restrictions to these sketch blocks, and they're going to interact as if they're parts. So it's a really good tool to use sketch blocks, add restraints and constrictions, and so you're able to see motion and how they're going to interact with each other. In the next few tutorials, I'm going to be showing you how to use the traction relation with sketch blocks. So you're going to be able to see how you're able to add traction between each of these sketch blocks. And from there, you're also able to use just the other constraints that you're already used to in between them all. So you can make them tangent, fixed, and you can add relations. But in the next few tutorials, I'm going to show you how to use the traction within sketch blocks. So just click OK. And that concludes our tutorial on sketch blocks within Solidworks. This is tutorial number 182, and it covers traction wheel-on-wheel within Solidworks. To start off, let's open up a new tutorial part. Let's click File, click New, click Part, click OK. So how we're going to be applying traction to two wheels is we're going to use sketch blocks like I showed in the last tutorial. So what we're going to be doing is we're going to be creating multiple sketch blocks with different wheels, and we're going to be rotating them and seeing how they interact with each other. Now you'd want to do this if you're trying to create like a gearing ratio or something, and just interaction between two circles, because you can see how the ratios are going to work and how everything's going to move around. So to start off, let's make our sketch blocks. So let's click Sketch, click Circle, click the front plane, and just create two circles. Now let's dimension both of them. So let's make this one here, let's make it 30, and we'll make this one here 50. Now in both of them, click the center line, click the center point, and just touch the outside anywhere on the outside of the circle. Do the same with the other circle. Now we're doing this so that when we create our traction between the two, you have a point to grab onto, and you'll also have kind of like a reference. So you'll see this line moving around and around. So now let's click Tools, click Blocks, click Make. So let's make our first sketch block here. So we'll click this sketch, the circle, and the center line. Click OK. And we'll do the same to this one here. Let's click Tools, Blocks, Make, click the circle and the center line, click OK. So now we have two sketch blocks and we're able to create a traction. Before we do that though, you kind of want to fix one of the circles so that it has kind of like a pivoting point in the center. So let's click the center point here and let's add a relation and we're going to fix it so it doesn't move. So click OK. So now that center point will not move. Now to add a traction between the two, click this sketch block, press Control and click the other sketch block, and now you have the option to do a traction. You can also do this just by going through the add relations. Click traction, and now you'll see that it automatically becomes tangent to that circle. Click OK, and now you're going to see that when we move one circle, the other one's going to move too. So click this point here and begin rotating it. And you're going to see that the other circle is also rotating. So like I said before, you're able to do this and kind of show and demonstrate gearing ratios and just how everything with the circles, how they interact and how they'll be moving. So if you click the other one though, as it's not fixed, it's going to be able to move around and react as such. So you're going to want to also fix this one too once you find a position for it. So let's move this guy down to here and let's fix it. Click the center point and fix. Now you're also able to do multiple, more than two tractions between circles. So let's make one more circle. Click circle and let's make a really large one out here. And let's make it 200. And we'll do the center line again for it. And let's click Tools, Blocks, and Make. And we'll click the line and the circle. Click OK. And now we have another sketch block. So now let's mate this sketch block to this one here. So we'll click this sketch block, click Control, and click that one. Let's add a traction. Click OK. Now let's fix the center of this one too. So let's click Add Relation, click the center point, click Fix, click OK. And now you're able to grab the original one that we had, move it around, and the small circle will move, and the large one too. So now you get to see the interaction between multiple circles. So like I said, for gearing, for pulley systems, whatever it may be, this is a great tool to simulate what's going to happen and just to see if you're going to run into any problems, and just a great simulation tool. And just again, you're able to choose any of these circles as we've mated them, and you're able to move them around. And the large one too. And that concludes our tutorial on how to use the traction wheel-on-wheel within SolidWorks. This is tutorial number 183, and it covers how to use the traction wheel-on-edge feature within SolidWorks. To start off, let's open up a new tutorial part. Let's click File, click New, click Part, click OK. So we're going to be covering the traction wheel-on-edge feature, and what this is going to resemble is a wheel and an edge moving together like a rack and pinion. So you'd use this kind of like to mock up a rack and pinion that you're developing, and just to see the motion and how it's going to move together. Again, we're going to be using sketch blocks. So to start off, let's start sketching it out. So let's click Circle, click the front plane, and let's draw a circle, and let's dimension the circle to 50. And let's put the center line in it from the center point to the edge again so we can see the movement. And let's click Tools, Blocks, Make, and let's make our sketch block. So we already have the line selected. Now let's click the arc, click OK, and now we made our first sketch block for our rack and pinion. Now let's click and let's make a rectangle. Let's just drag it out and let's dimension it. So let's make the side, let's make it 15, and we'll make this 500 long. Click OK, and now let's click Tools, Blocks, Make, and we'll make this a sketch block. So let's click each line. Click OK. And now we've made our second sketch block. So now let's create the traction relation between the two. First off, let's just fix the circle. So let's click the center point, click relations, and fix it. So now the center point and the circle will not move. Now let's click one sketch block, click Control, click the other, and let's click traction. Click OK, and now we have our traction. So let's move it around, and you can see how as we move the circle, the line and the edge is also moving in contact with it. So let's zoom out of it just so you can see. So as I said before, this resembles like a rack and pinion, and it can be any type of machinery or any system that you're trying to mock up to put together. So again, this is just another way of utilizing the traction feature, and it's just a great example of how you're able to simulate using the drawings and the drawing blocks within SolidWorks. And that concludes our tutorial on how to use the traction wheel on edge feature within SolidWorks. This is tutorial number 184, and it covers how to use the sketch belt and chain feature within SolidWorks. To start off, let's open up a new tutorial part. Let's click File, click New, click Part, click OK. So in this tutorial, we're going to be covering how to use the sketch belt and chain, and we're going to be using the same kind of tools that we use in the past few tutorials with the traction to create sketch blocks and then create a belt and chain that's going to go around a bunch of circles or gears. So to start off, let's make our circles and gears. So let's click Sketch, click Circle, click the front plane, and let's make one circle up here and make the center line. Make a circle over here, right across from it, and let's make it the same diameter and put another center line. Now we're going to have to make the sketch blocks again, so let's click Tools, click Sketch Block, click Make, and we already have the line highlighted. Now let's highlight the arc, click OK, and we'll do the same for the other one. Click OK. So now we have the two sketch blocks, and now what we're going to do is we're going to link them up with a chain. Now first let's fix both of these. So let's click the Add Relations and fix the center points. And you'll notice that you're able still to turn them around, move them around, but they're not touching each other or moving each other at all. So now let's add the belt and chain. So let's click Tools, Sketch Entities, and let's click Belt and Chain. And what you have to do is select the sketch blocks that you want to add into it. So you can either click them from the tree or just click them from the sketch. So now we've clicked them, and now we've created a belt. And you can see the belt is in yellow, and you're able to change the direction. And of course you don't want to have it going around like this. You'd want it the other way. So you just have to play around with these arrows until you get the way you want it. And when you're clicking your belt and chain, you want to click in the order that you want it to go in. So now this is the belt and chain that we want on this little sketch. So let's click OK. And now if we move one of the circles, even though they're not touching by the traction, you can see that the other one's moving because of the belt. Now, let's get rid of this belt, and let's add another circle. So let's add one down here, and let's make this one bigger, and let's put another center line in it. And let's make another block from it. And now let's add these three together to make a belt and chain. So let's click Tools, Sketch Entities, Belt and Chain, pick the three circles, and you can see that we have another belt and chain. And again, you're able to move these around to get the shape that you want and the path that you want. And just remember, go in the way that you want it to go in. Now we have our belt and chain, click OK. And again, if we start moving it, everything else is going to start moving too. So this is like the traction, except that you're using belt and chain, so it's going around. Now, if we go back into this belt and chain that we just made, if we click Edit Belt, and if we make this driving, I've fixed the points of these two, so these two circles here will not move, but this one is still free to move. So if I make this driving, and if I change the length to, say, 800, now this circle is going to move. If I make it 600, it's going to pull in. So now we have a driving dimension, so we're able to play around with like the length. So say that we had an 800 millimeter belt, then with the, you can call them gearing, circles, pulleys, whatever you want. With the pulleys that we have, it's automatically going to move the free one around so that it fills up the 800. And that concludes our tutorial on how to use the sketch belt and chain within SolidWorks. This is tutorial number 185, and it covers the assembly belt and chain feature within SolidWorks. To start off, open up tutorial part number 185, ASM. So what we have here is the assembly that we're going to add a belt and chain to. So what we have is just the block, 2 wheels of the same size, and 2 wheels of another size. So what we're going to be doing is we're going to add a belt and chain to this assembly. Now, in the last tutorial, we used sketches, and this time we're going to create a sketch from the 3D. So the application of this would be if you're creating, again, like a pulley system or a gearing ratio, whatever, that there's going to be a belt or chain on, you can mock it up and create your sketches off of this. So to start off, to get to the belt and chain feature in the assembly, you have to click Insert, Assembly Feature, Belt and Chain. And just like when we use the sketch blocks, you just have to go around and click on which circle or which gear or wheel you want to use first and go around in the order that you want it to go in. So to start off, let's click this one. Then we'll go to this one here, and then this one here. Now we're just going to have to flip this one around, and now we have our pulley system that we're looking for. Now, like the other one, we also have the option of driving it, and we drove it last time because 2 of our circles or pulleys were fixed and 1 wasn't. In this case, all of the pulleys that I have are fixed, so we can't use the drive. So right now we have our pulley system, and the last one, or whichever one you have highlighted here, you're also able to change the diameter. So if you keep making it larger, it's going to go larger. If you make it go smaller, it's going to go smaller. So it's just to play around with the belt and the size and what it's going to look like. So you can play around with it, and if you make it too big, all you have to do is press 0, press enter, and it's going to put it back to the original dimension that you started out with. So for this one, we've got our belt and chain that we like. It looks good, fits everything how we want it. Let's click OK. And now we have our sketch for it. So now all you have to do is from this sketch, extrude it out and make whatever it is your belt is. Like how thick you want it, if you want teeth. If you don't want any teeth, it's up to you. Now let's delete this belt. And let's go through these mates, and we're going to delete one of these concentric mates. So let's delete this one here. And if we grab this guy, you can see that we can move him around. But he's always going to be parallel. We need to make him parallel to that face. So let's move this back around here. And what we're going to do is we're going to make a driving dimension, and then this guy's going to move around. So let's do Insert, Insert, Assembly Feature, Belt and Chain. And let's go around and do all of our belts and chains again. So let's click this guy, this guy, this guy, and then this guy. And we'll flip this one around. And this time, let's make it driving. So let's put it up to 2,000. And you can see when we do that, it kicks out that chain there. So let's do this again. Let's edit feature. And let's pull it into 1300. Click OK. And you can see that it pulls it in. So you're able to drive this again. You just have to have at least one belt that isn't intact. Or sorry, one pulley that isn't mated and can move around. The other ones have to be fixed. And that concludes our tutorial on how to use the belt and chain in the assembly. This is tutorial number 186, and it covers how to use the spell checker within SolidWorks. To start off, let's open up a new drawing file. Let's click File, click New, click Drawing, click OK. Click OK for the sheet size, and exit out of the model view. So what we're going to do is we're going to go through and I'm going to show you how to use the spell checker. Now, of course, the reasoning behind using a spell checker is to make sure that everything's spelt correctly on your drawing, and this will eliminate any confusion if you have to hand it off to a machine shop or get some quotes done for any of your parts. Everything's spelt right, everything's correct, so there's no confusion. Now, what we're going to do is we're going to open up the sheet and double click on Sheet Format. Now, let's double click on this here and let's copy it. What I'm going to do is we're going to delete a few of the letters out of here and then do the spell checker. Now, I would do it in this sheet that we have right now. The only thing though is, if I was to run the spell checker now, it's going to notice things such as this, which when you go back to the sheet is correct, but in here it's going to want to check the spelling on that, and we're going to have to ignore a lot of things. So I'm going to go back to this sheet here. So let's double click, and let's click Annotation, click Note, and let's put a note up here. And from what we copied down there, let's paste it here. Let's double click and let's edit this. So let's delete a few things here. Let's get rid of these plus minus. Get rid of all of this. Now, let's delete a few letters. So for the dimension, let's take away the E. For the tolerance, let's take away the A. Fractional, we'll take away the N. And for place, we'll take away the A. Now accept it, and let's run the spell checker. So now the spell checker is going to go through all the words, and it's going to show you which ones are spelled incorrectly. Now for dimensions, it found it, so let's click Change. So we've selected dimensions, now let's click Change. Again, for tolerances, let's change it. Fractional, let's change it. And place, let's change it. It's found everything, it's complete. Click OK, and your spell check's done. Now, if we click the spell check again, it's going to go through, there won't be any problems. Then you're good to go. Now, spell check in here, it works exactly just like your Microsoft Office. It'll run through just like it showed you and give you the suggestions, and it'll give you the option to ignore or change it. And that concludes our tutorial on how to use the spell checker within SolidWorks. This is tutorial number 187, and it covers exporting parts and assemblies within SolidWorks. Now, the reason you need to be able to export parts from SolidWorks is that because everyone in the world won't be using SolidWorks that you're going to have to interact with. Now, if you create a model or an assembly or a part that you need to get either a quote or for people to view and get their opinion on, you're not going to be able to just send your SolidWorks file. They may be running a different CAD system completely. So you need to be able to export your SolidWorks model into a file format that they can use. So as there's, many different types of CAD programs, there's some standards that we can create our model files in that everyone can view. Now I'm just going to show an example that this engine block that I have in SolidWorks, I've exported it and it's able to be viewed in CATIA. So I exported it, and now you can see the exact same engine block in CATIA. So this is just like an example that from one designer to another, I'm able to create the part, export it, and send it to someone else, and them using a totally different CAD system can still open it up with the same results. Now in the next few tutorials, what we're going to be doing is I'm going to go over a few more standardized exporting file types, and we're going to export parts and assemblies, and we're going to open them up in another CAD system such as CATIA. That concludes our tutorial on exporting parts and assemblies within SolidWorks. This is tutorial number 188, and it covers how to export step files within SolidWorks. To start off, let's open up an assembly. Let's click File, and let's open up the 90 wheel assembly, which is located on the DVD. Now this is a tutorial part that we used previously, and what we're going to do is we're going to export a single part, and then we're going to export the entire assembly. So to do this, whenever you're exporting any step file, all you have to do is click File, Save As, Save Type, and then choose a step. Now for step files, you have the choice of the AP203 or AP214. I prefer the 203 as I find that it gives me the most consistent job from job to job, and the 214 sometimes I find some irregularities and sometimes I find some foreign objects in there. So we're just going to be sticking to the 203 for the step file in this case. Now the first thing we're going to do is we're just going to export a single part. So we're going to export this part here. So just click on it and then click on the part in the tree, then go File, Save As, turn it into a step file, click Save, and then it's going to ask you if you want to export only the selected part. We only want the one part, so yes, we only want to export the selected part. And now SolidWorks has exported it. Now I'm going to go into CATIA and I'm going to try to open it up. So let's click File, Open. And I've successfully opened up that step file from SolidWorks. So if we flip back from one to another, you can see that it is the same part. Now let's try to do the entire assembly. So when you're doing an entire assembly, try to go up the tree as much as you can, double click on it, and you have the entire assembly selected. So now let's export it the exact same way. Let's click File, Save As. We'll do another step file, and we'll call this one the ASM for assembly. And now it's exported it. So let's go into CATIA and let's try to open it up. Let's click File, Open, the assembly, click OK, and we've opened up the step file. So now we have one that's the entire assembly, and we have another one that's just the one part that we exported. So if we flip back and forth between the SolidWorks version and the CATIA version, you can see that they are the same. So we're able to successfully create this part in our earlier tutorials, and now we've been able to export it and send it to another CAD system. And this concludes our tutorial on how to export step files within SolidWorks. This is tutorial number 189, and it covers how to export IGES files within SolidWorks. To start off, open up tutorial part 90_wheel. Now this is a tutorial part that we made before, and it's the same one that we used in the step file exporting. So what we're going to do in this one is, again, we're going to export a single part, and then we're going to export the entire assembly. So to do this, let's click on the dish inside first, and let's export it as an IGES file. So let's click File, click Save As, and for the save type, let's click IGES, and click Save. And it's going to ask you again, do you want to only export the selected objects? We only want the part, so let's click Yes. And now it's created the part. Now we're going to go to CATIA, and we're going to try to open it up. So let's click File, Open, and let's click IGES. And again, it's opened it up. And if we look at the SolidWorks compared to the CATIA, it's exactly the same. Now let's do the same for the assembly. So let's click on the entire assembly, click File, click Save As, and let's do another IGES file for the assembly. And for this one, we'll click _ASM, and now it's going to export the entire assembly. So now let's open it up in CATIA again, and let's see what we get. And in CATIA, we get the entire assembly, just like we wanted. And if we look at this one compared to the one in Solidworks, again, it's exactly the same. So again, like the step file, we were able to create this part file before in our earlier tutorials, and now we were able to export it as an IGES file to another CAD system. And this concludes our tutorial on exporting IGES files within Solidworks. This is tutorial number 190, and it covers exporting Stl files within Solidworks. To start off, open up tutorial part number 90_wheel, which is included on the DVD. This is the same tutorial part that we've been using in the past few tutorials. Now what we're going to do in this tutorial is export it as an Stl file. Now an Stl file is a file format that you would use when you're sending your file or your product to be created as a prototype. So an Stl file is a file format that they would use to create a layered version of your part file. So you probably get it back as either plastic or some kind of polymer that they would use. Now in this case, we're not able to make a complete assembly. So when we click on the assembly, it's going to make an Stl file for each one of these parts. So let's do that. So let's click the wheel here, click File, Save As, and let's choose Stl. Click Save, click Yes, and now we've created our Stl files. So let's open them up in SolidWorks. So let's click File, Open, and change the file type to Stl. And now let's open the 85, click Open, and we have an Stl file of that part. And let's open the other ones too, just to make sure they're all right. Click Open, Stl, let's do 83, and we'll do the same for the last one. And you can see that in these file formats, they look good, and this is what they would get if we sent it to a prototyping shop or to send it to a machine that would use an Stl file to create your part. And that concludes our tutorial on how to use and export Stl files within SolidWorks. This is tutorial number 191, and it covers layering parts within SolidWorks. To start off, open up tutorial part number 191A and 191B, located on the DVD. Now, layering parts is kind of like comparing the original to the modified part. So what we're going to do in this tutorial is that I've already made beforehand a couple parts that have been modified just slightly to one another. So 191A is the original, and then 191B is the modified one. And obviously you can see that it now has this bump here. This whole profile here has been extended out a little bit, and we've added a chamfer, fillet to the bottom there. So what we're going to do is we're going to layer each of these parts just so you can actually see the changes made from the original to the new one. And you can also do this so that you can see, you can display and kind of show others the changes that are going on between the two. So it's more of a visual way, a lot easier to see rather than just pointing out, like I did before, that this has changed, that's changed, and now that there's a fillet there. So to layer these two parts, what we're going to have to do is create a new assembly. So let's click File, click New, click Assembly, click OK. Now let's click View Origins, and let's throw both of the assemblies onto the origin. So click 191A, and let's put it onto the origin. And let's insert 191B, and we'll put it onto the origin. Now these two parts are both layered on top of each other, and you can obviously see the differences. So you can see the profile change here, how it's all been pushed forward. You can see that this is completely new compared to the green. And if we go down here, you can see that there is no yellow at the bottom there, and that it's been cut off and chamfered off. So this is just an example of how to layer and kind of show the difference from, say, the original to the modified part. Now, these changes, some of them are easy to see, but when you're actually doing it, some trim line changes might be very, very small. So a good idea is to throw it into wireframe so that the person can see the original compared to the new. And you can see it in here. That's the original, that's the new. And if we go down to here too, you can see the chamfer compared to the straight edge there. So you're able to throw it into a wireframe. You can throw it into 3D form, move it around, let them see. So it's just a great way to really show and explain the changes from one design to another. And that concludes our tutorial on how to layer parts within SolidWorks. This is tutorial number 192, and it covers the hotkeys within SolidWorks. In this tutorial, what I'm going to do is I'm just going to go over a PDF file that I've put together that's included on the DVD. So if you open up on the DVD the hotkeys PDF, what I've done is I put together just some basic hotkeys that you're able to use while you're using SolidWorks. So things like opening and closing a document, how to move around with like the arrows, how to look at different views. So it's just a quick, easy reference for some of the hotkeys, just so you can increase your productivity and it's just easier for you to use and whatnot. So I'm just going through this just to show you. So as you can see in here, Control N opens a new document. So if I go back to my SolidWorks, and if I press Control N, I get my new document. So just by looking off of this reference sheet, you're able to do just some tasks a little quicker. If you're using SolidWorks day in and day out, you're going to be able to get really good at this and just quickly and easily just press the buttons that you need, and you'll get your views, your new document, whatever it may be. And that concludes our tutorial on the hotkeys within SolidWorks. This is tutorial number 193, and it covers the multiple view windows within SolidWorks. To start off, open up the Engine IGES file, which is located on the DVD. So in this tutorial, I'm going to show you how to make multiple view windows of a single part or single assembly. Now the reasoning behind this is if you want to look at a part, an assembly, multiple ways, different views, different states, either solid, wireframe, it's up to you. So to add more views and to get more windows of different views that you can manipulate individually without changing the other views, to do that, what you have to do is click Window, click New Window, and you're going to get a new window of that same part. So if we go and look at all of our windows, we have 2 of the engine. Now let's tile these horizontally, and if we click this window, we can move him, and if we click this one, we can move him. So in the window at the bottom, let's change it to wireframe. And the window at the top, we have it as a solid model. Now let's look at this guy from the front, from the back, from the left, from the right. So you're able to set it up, so let's say, put this one at the back, create a new window, put this one to the left, create a new window, and we'll put this one to the right. Now if we tile these, now we have 4 different views of the same part, same assembly, all at once. So this allows us to look at the same problem, same aspect in different views, different orientations, and it's just able to get you to visualize what's going on in all different directions all at once. If you only had one window open, you'd only be able to go through these views one at a time. As we have 4 right now, or even more, you're able to kind of flip through the views a lot quicker, and you can design from them. This is a great tool to help you optimize your designs and help you to visualize and see where everything's going in together. And this concludes our tutorial on multiple view windows within SolidWorks. This is tutorial number 194, and it covers time dependencies within SolidWorks. To start off, open up tutorial part number 194, which is located on the DVD. Now, time dependencies, what it means is that the part and the tree is all time dependent. As you go through the tree, everything gets built together, so depending where in time each part is built, depends and will determine what the final result will be. So every time you press rebuild and try to rebuild the model, it's going to make this extrude, then this move. That will result in your final body, in your final assembly. So each time these are in a different order, you're going to get a different result. Now I'm going to show you an example of playing around with the order and the time dependency of a few features and the results and the different results you're going to get. So to start off, let's do a fillet. So let's click fillet, and we're going to do a 5mm and click this top face. Click OK, and you'll notice because we have two bodies, it's only doing a fillet around this edge here. It's not touching and making a curve or fillet around these two faces. Now if we do a combine add, so let's click insert, click feature, combine, and if we add these two together, click OK, now we have one body. And if we pull this fillet below here, we should have a fillet around here and the fillet touching these faces here. So let's pull the fillet below, and now we have a fillet on the edge of the block and the two blocks touching each other. Now if we pull the combine below it, we'll only have the one. So as you can see, this is dependent on the order of which these two parts are put together. As we change the order and the time dependency, so will the part change. So this is just a quick and easy example to show you how each part you make is time dependent. So if you run into some kind of problems with rebuilding your model, you need to look at the tree and how everything's being put together. And this concludes our tutorial on time dependencies within SolidWorks.